Hello, everyone. Today I'll be presenting on creating effective privacy labels. The work was developed in collaboration with AJ, Jayati, Peter, and Gene Camp. Today, the user is solely responsible for protecting their privacy. It doesn't matter if they're browsing the web, using a mobile application, or an IoT device. They are responsible for protecting their own privacy. This is a pretty big ask, especially when you consider that they're presented with little to no information at the time of decision making. Say you want to install a meditation app. As you can see, there are quite a few options. The App Store provides you with metrics that tell you how many people found the app to be useful and the number of downloads an app has. But you have no information about the privacy offered by the app. How do you make a privacy-preserving choice when you have no way of comparing these apps based on the privacy they offer? Therefore, privacy labels are needed to empower users to make informed decisions. But then, what does it take to build an effective label? Well, there are 4 primary components that make an effective label. Labels must reduce information asymmetry. They should reduce the cognitive burden on the user, account for psychological biases, and should be personalized. Information asymmetry occurs when the buyer can't distinguish between high-quality and low-quality products. For example, the used car market is also known as a lemons market because the buyer does not know if a car has pre-existing defects. So only people with low-quality cars will want to sell their cars. An obvious way to reduce information asymmetry is to present relevant data collection, usage, and retention practices. However, oftentimes, this is presented in a manner that increases the cognitive load on the user. Take privacy policies, for example. While they offer some insight into data collection and usage practices, they are lengthy and unusable. Craner and McDonald estimated that the cost of reading privacy policies alone is in the billions. Additionally, some privacy policies require high levels of literacy for you to understand its contents, causing most people to just ignore them. So privacy labels, while reducing information asymmetry, should not increase the cognitive burden on the user. A user should not be required to read multiple pages to understand the privacy offered by a product. The label should instantly convey the privacy offered by a product. At the same time, it should enable users to compare between products with little cognitive effort. These requirements should be met while decreasing information asymmetry. Modular privacy labels are our best bet, as they can both reduce information asymmetry and cognitive burden. Here, the first layer presents users with an aggregate rating which instantly conveys the privacy offered by a product and enables quick comparisons between products. The second layer contains text that provides more context about the data collection and usage practices. This area can also be used to highlight the data collection and usage practices that the user cares about, but should not be displayed by default because it has non-trivial cognitive cost. In addition to reducing the cognitive burden on the user, we must also ensure that the label and the interface do not introduce psychological biases that negatively impact users' privacy behavior. Anyone familiar with SAS, Kapadia, and Craner knows this is true. For instance, positive framing is known to be more effective than negative framing. So positively framed privacy ratings using the padlock icon elicit a more privacy-preserving behavior when compared to negatively framed privacy ratings, which utilize the eye icon, where the loss in privacy is conveyed as opposed to the gain in privacy. Similarly, endowment effect also has an impact on user behavior. Here, the value a person attributes to a good varies based on if the person possesses the good or not. What does this mean? Once you perceive ownership of something, it's more valuable to you. For example, in class, my professor gave away free RSA swag T-shirts to every student in the class. She basically stood at the door and made each of them take one T-shirt. We did not particularly want them, but she made us take it. A week later, she tried to buy them back. Nobody wanted to sell them. Even nobody wanted to sell them for like even less than anything less than $10. So in a week, the price of a free T-shirt essentially went up to $10. So ownership matters, and that's essentially what endowment effect is. In the context of privacy, what this means is that users are less likely to give up privacy in exchange for a monetary compensation. At the same time, they are less likely to pay an additional amount to protect their privacy. For example, we conducted an experiment with three different versions of an IoT marketplace. The control version of the marketplace did not have any privacy information about the product. It just had price and product description. The willingness to pay and the willingness to accept interfaces had the same privacy, had provided users with privacy information and also presented them using the same indicators. But they emulated different framings. All three versions of the marketplace sold the same products, and the products that offered better privacy were priced higher than the products that offered lower privacy. The results from this experiment showed that participants using the willingness to accept version of the interface were willing to pay 30% more when compared to the remaining two groups. The more interesting finding here is that we did not find any difference between the control group and the willingness to pay group. In other words, the impact of the privacy label was negated by the psychological biases introduced by the interface. Defaults also matter. Status quo bias states that people are more likely to stick to the default. This is because people are inherently loss-averse and fear the potential negative consequences that could arise from moving out of the default state. For example, Apple's transparency tracking is enabled by default. So any app wanting to track a user across apps has to get consent from the user. So far, 11% of the users worldwide have only 11% of the users worldwide have enabled apps to track them. This demonstrates how strong of an effect defaults have. Finally, privacy preferences vary from person to person. So it is important that privacy ratings are personalized for each user. Machine learning models can help here. For instance, we found that we could accurately estimate a user's comfort for sharing a given data type by looking at 5 factors: the device type, the perceived sensitivity of the data type, perceived benefit, perceived trust, and perceived risk associated perceived risk associated to personal safety. The predicted comfort for each data type collected by a product can then be aggregated to generate a privacy rating on a 5-point scale. To summarize, labels are needed to make informed decisions. And for privacy labels to be effective, they need to address information asymmetry, reduce cognitive burden, account for psychological biases, and should be personalized. Thank you. Any questions?